So welcome back everyone. Now we are going to learn about the types of memory, and let's start with the direct mapping. So what is the direct mapping? Well, as you can see, I have made a rough diagram here right here so that we can understand that what is the main memory and what is the cache memory. So as you can see, there is a cache memory that contains only the index thing, and in the main memory there is tag as well as the index, so it contains both of the things. So, in this technique, each block of the main memory has only one possible, only one possible location in cache memory. In cache memory, or let's say cache organization, whichever way you like to call it. So, one for one, and that's the meaning of it. Like main memory is here, and the cache memory is here. So one thing for one thing, it's one on one. That is the meaning of the direct mapping. And as the name indicates, it's directly mapped. So this is one for one, and this simple it is. Okay, now let's proceed to the next one, which is our associative mapping. Well, in the associative memory, it stores both the address. Let me also write that. It stores both the address plus data. As you can see right in the front of this diagram, it is storing address as well as the data in the memory word. In let's say just memory, in the memory. This permits any location in the cache to store any word from the main memory. It can store anything. The cache memory can store anything from the main memory, and this is the advantage that we get in the associative mapping. And we do not necessarily need the one for the one and two for the two. We can have three for the two and one for the three, and this kind of things. So this is the way we can define our associative mapping. When a CPU generates a memory request, the address is searched in the address field of an associative memory. If the address is found, then data is read from the memory, otherwise it's a mess and we have to go to the main memory. So that's the complete thing that we have to study in the associative mapping. Okay, let's proceed to the third one, which is our set associative mapping. In the set associative mapping, we have indirect mapping, two words with same index in their address but different tags. As it is, I have not mentioned the tag here, it's having different tag. We have to mention something different. It's different tags. We can have two words just determining the length, the byte of it, that's it. Two words with same index. We can have two words with same index, but we have to mention its different tag. Like you can have the two chapters naming the same way, but you must have to have it in a different tag, like chapter number 1 and the continued chapter number 1, that way. So both are chapter number 1. So in the index you can see both are chapter number 1. You are storing the two words, but you are mentioning that it's the chapter number 1 and the 1 continue. So you are tagging it differently, and that was the difference. But in the set associative mapping, you can have same tag, and in that you have we do not desire, actually we do not need to have more tags. We can have only let me write it again, only one tag and multiple index and multiple words or data, whichever way you like to call it. So this is the difference. And in this one, what we are having, we can have multiple things at the same point, but still we need to mention the different tags of it. And in the direct memory, it's one for one. So it's the simplest form, one for one, only one for one. So you have one tag, one index, and one word. One tag, one index, one word. So I hope it becomes quite clear to you right now that what we are talking about, and this is the example that I mentioned up here. So in this same tag, we can have the different data, and we do not require more tags. Like I just wrote here, but we do not need actually that kind of more tags. The diagram that shows here is a two-way set associative memory. Here, each index word represents two data words and their set associative tags. So that's the way how the set associative mapping is actually working on. I hope you have got the idea of these mappings and the types of mapping. Now we reach to a point where we have to study our most interesting thing, which is virtual memory. So we will continue the virtual memory in the next one. Till that time, take care, God bless, and keep learning, my dear pondering students.